Hello everyone. I just wanted to walk you through what the lab exercise for this week is going to be. To start off, a little bit of a review. This is the slide from last time. Here we have a set of X and Y data, and we want to see what the trend of that data is going to be. So the best way to do that is to plot it and get the best fit line. And then as a reminder, the equation for a line is y equals mx plus b. Y is our vertical data, m is the slope of that line, x is the horizontal data, and b is the y-intercept. And we're going to use Desmos again to get the numerical values for the slope and the intercept. So this week we're going to be looking at the acceleration of the object due to a force that we're going to be applying to that object. So let's say here we have this car that's a neutral, we apply different forces to it, and we measure the acceleration. Well, how are we going to plot this? And what does the slope and intercept mean? What do we expect it to be? We're always going to start with a physics equation. In this case, it's Newton's second law. Net force equals ma. I'm going to add a little plus 0 here to make it a little more obvious. So the equation for a line is y equals mx plus b. So you see how these are in the same form. The force data is in the position of the y. The acceleration data is in the position of x. So if we plot force on the vertical axis, acceleration on the horizontal axis, we can see that in this case, m is the mass of the object, and the one down here, m, is the slope of our line. Then we expect our experimental value for the mass of the object is going to be the slope of the line, and we expect the intercept to be 0. So that's how we're going to be plotting our data, and that's how we're going to be determining what the mass of our object is going to be, is through this method here. So there's 3 steps. We're going to use this simulation, and here we have this box of unknown mass, and we're going to be changing the force on that box and recording what the acceleration is going to be. So I tell you a bunch of different forces that you're going to use, and I'm going to have you record the acceleration for each of those forces. Then we're going to go to Desmos, and we're going to plot the data up. So just like before, force on the y-axis, acceleration on the x-axis, our experimental value for the mass will be the slope, and our expected value for the intercept will be 0. Once you've done with all that, there's a bunch of questions you're going to answer in the module for this week. Let me walk you through how to do the simulation. So when you go to the link, you're going to arrive at this page here. You're going to click on acceleration, and you're going to click on it again. And there are a bunch of settings that we're going to change here. We're going to take friction and go all the way down to 0. So now it's ice, so frictionless. We want to show what the acceleration is, so we click this. And we want to show what the values are, so we click this. Now we're not going to do this box, so just like before, we're going to click and drag this present up here. And then we're going to increase the force down here, and we're going to measure the acceleration. So if I increase the force to 50, we see that we have an acceleration of 1, and this will be your first data point. Now, eventually you're going to get pretty high acceleration, and eventually the person's going to lose contact with the box, and that's fine. You'll just have to click this reset button and change all the settings back again so that you can start the experiment again, okay? Now, once you get all of that data, we're going to go over here to Desmos. And this will be a new link, so don't use the link from last time, as I inputted the forces that I want you to put here. So our first data point with 50 newtons was an acceleration of 1. See, our green dot is the data point, and the red is the best fit line. So as you record the rest of the acceleration for these specific forces, you can see that the slope over here and the y-intercept will be recorded in Desmos. So you'll take those values, and you'll answer the questions in the module for this week. I hope that helps. Let's get to it.